We'll add EBS volumes in two different ways. One during launching the instance and second after the instance is launched. Let's launch an instance and add a volume while doing so. I'll add a volume here and give it a size of, notice the highlighted portion. When you add a volume, you have to provide a device name. Just keep that in mind that the device name is /dev/SDB. We already know what GP2 is. We can change the volume type if you want. As the volume size is 5 gigabytes, the minimum IOPS is 100. Now there's one more flag which is delete on termination. So if I check this box, what will happen is when you terminate the instance, the EBS volume will also be deleted. We should not do it for production because, as mentioned earlier, the life cycle of EBS volumes are different than that of EC2 instances. So you should not terminate or you should not delete your EBS volumes when your EC2 instances are terminated. It can be used for purposes later on. And finally, we have encryption. We can encrypt volumes. Encryption does not charge any extra money. EBS volumes can be encrypted at free of cost. So look into encryption later on. Let's go ahead and launch the instance. EC2 instance has been launched. Let's log into the EC2 instance and see the device types. I'm logged into the EC2 instance. If you want to see which devices are attached to your EC2 instance, you'll have to type this command lsblk-p. Now there are two devices if you see. One is /dev/xvda and the other one is /dev/xvdb. You go to your EC2 console and look at the block devices. The root device is /dev/xvda. In the block devices, we have /dev/xvda and one more, which is SDB. Now, SDB is the additional volume which you have attached while launching the EC2 instance. The same device is being represented as /dev/xvdb. The name changes from SDB to XVDB because of virtualization reasons. This device is actually the hard disk which we discussed in our pre-EBS talk. We have not attached or allocated this hard disk to any of our file system. Let us go ahead and create a file system. pwd is the command to see which file system you are in or which working directory you are in. So currently I am in working directory /home/EC2 user. Let me go ahead and create a directory. The name of the directory is EC2mo. You can type this command ls-l to see whether the directory has been created or not. If you see here, there's a directory named EBS-demo and the type is directory because the first character is D. Now before allocating or attaching the device to your file system, you'll have to format the device. Think of it this way. When you go to market to buy an USB drive, you get the USB drive and you can plug in directly to your system or device and you can use it directly. The reason for this is the pen drives or the USB drives are pre-formatted. But that is not the case in case of corporate storages. All these devices are raw devices. They are not formatted. Basically, they are unformatted devices. You have to format it as per your file system. Then you can use it. In Windows, the file systems which work are NTFS and FAT. But in Linux, the file system names are different. These are the file systems which are supported in Linux or any Unix-based operating systems. ext2 is almost obsolete now. We should not use ext2. Neither should we use ext3. The newer file systems should use ext4 or XFS type. You can use this command to check whether the device is formatted or not. If the output is data, that means the device is not formatted and you have to format it. I'll format this device, which is /dev/xvdb with type ext4. And the command is, what this command will do is, it is saying that make a file system with type ext4 with the device /dev/xvdb. The device has been formatted. Let's use the file command again. Now it says the file system is something else. It says ext4 is the file system. So I have formatted the raw device. Now I'll have to attach or map this device with a file system. So the directory which you created was EBS/demo. This command is used to map the device with the file system. That means after the mapping is done, whatever you write in this file system will be saved in this hard disk, the way we discussed in our pre-EBS talk. Once this is done, if you type lsblk-p again, you will see that this device has been mapped to the file system /home/ec2user/ebs demo. Now I will create a volume and I'll attach that volume to the running EC2 instance. Currently, this EC2 instance has only two devices as we have seen so far, /dev/xvda and /dev/xvdb. I'll attach a new one. Go to EBS console, click on create volume, mention the size, I'll mention it as 2 gigabytes. Remember the AZ has to be same as that of your EC2 instance. So what is the EC2 instance AZ? How can you know that? Go to the EC2 instance and click on this. Then you can find out the AZ which the instance is running on. In our case it is US East 1A. We'll create the volume in US East 1A region as well. We'll create the volume in US East 1A AZ as well. So the volume has been created. Click on refresh. You should be able to see the volume. The ID of the volume is AA31 and the state is available. The reason it is available because it has not been attached to any EC2 instance. We'll go ahead and attach this newly created volume to the EC2 instance. Click on the volume, click on actions and then attach volume. Select the EC2 instance which you want to attach the EC2 volume to. In our case, AWS Foundation EBS Demo, that is the name of our EC2 instance. Then click on attach. Notice the device name, it's SDF. Once the attachment is done, the state would be changed from in available to in use. If I type the command lsblk-p again, now I should see the additional volume in xvdf. As the volume name was SDF, it has been changed to xvdf, but it has not been mapped to any of the file systems. So we'll follow the same process. We'll format this device and create a new file system and map this device to that file system. Once everything is done, you'll see that the device has been mapped to the file system /home/ec2user ebs2. So we created a volume, we attached it to our EC2 instance and we made the volume usable by formatting it and then by mounting it to the file system. You can check the details about your volume in the description tab. Click on any of the volumes and at the bottom pane you'll see the description tab. Similar to EC2. This is the volume ID, this is volume size, this is when the volume was created, and the attachment information, which EC2 instance this volume has been attached to and with which device ID. The volume type, what IOPS we are slated to get out of this volume, the AZ and other information. To modify a volume, click on the volume, go to actions and select modify volume. You can change the volume type and the volume size. So from general purpose SSD, you can change it to any other volume types. You can change the size also. You can only increase the size. You cannot decrease the size. So current volume size is 2. If I change it, if I try to make it 1 GB, it'll give me an error saying that the volume size can only be increased but not decreased. So let me increase the volume to 4 GB and click on modify. So the volume size has been increased. From 2 GB it has been changed to 4 gigabytes. Let me go ahead and see what is the status in EC2 instance. I'm in the EC2 instance. If I type lsblk-p, I can see that the device size has been increased to 4 gigabytes. Let's see whether it has been reflected in the file system. Type df-h. This is the file system which was mounted on xvdf. Now in lsblk-p, it is showing me that the device size has been increased to 4 gigabytes. df-h gives you the file system mapping information. In the mapping, it is still showing that the file system size is 2 gigabytes. How do you increase the size? This command will resize the device as per the file system. Now if I type df-h again, now the file system size has been increased to 3.9 gigabytes. 0.1 gigabytes has been taken for internal reasons, but as you can see now, the device modification is getting reflected at file system level as well. Currently, I have three devices attached to my EC2 volume. First XVDA, which is the root device volume, then XVDB and XVDF. XVDB and XVDF are additional volumes which I had attached to this EC2 instance, and these are mapped to these file systems. Now, how do you release and delete a volume? To detach or delete a volume, first you have to remove the mapping between the device and the file system in EC2 instance. So to remove the mapping, you have to type this command. This command will remove the mapping of XVDB device and the file system /home EC2 user EBS demo. After I type this command, if you type lsblk-p again, you'll see that the mapping has been removed. After the mapping has been removed, you can go to the console and detach this device or volume from this EC2 instance. Click on the volume, click on actions, and then detach volume. Once the volume detachment is successful, the state changes from in use to available. After this, you can go ahead and delete this volume. Once you delete the volume, you cannot retrieve it in any way unless you have a snapshot, which is our next topic of discussion. A few final words on the demo. The commands which I have shown, which I have used like lsblk, mkfs, mount, as a solutions architect or AWS SysOps administrator, you won't have to use those commands. I have just shown those things so that you can practice it on your own and see and feel how EBS works.